at the sky. When the stars began to fade, dimming lanterns in our eyes. Thought there was nothing to find. I stopped searching for a reason. Just let the world embrace us. In the silence, we are one. Can't escape from this feeling inside you. Release from heartache, you'll be fine. When the cracks start to let you run light through, I'll be there to help you shine. Promise you this, as long as you're looking, you'll see the signs. Just for a moment, a flash of light, you'll never forget. I heard you crying aloud, and a part of me cried with you. I finally see why all the neat tears fall out of you. Can't escape from this pressure inside you.
Hello everybody, once again it is time for more manual reading. What kind of manual reading? We're also doing the pain in the heckin' butt where I will be tested. So that will be absolutely thrilling to do. Let me just wire up one little thing real quickly because I was just a little slow getting it all set up. The countdown's supposed to be here to help me do the setup, and I am mistaken. There we are. Messages are working. Huzzah. We are working. We are grooving. We are good. And I have a feedback loop of background stuff playing right now because heck yeah. Why do I have that being shown right now? That should not be what's being shown. That's not what's shown. Not application capture, display capture. There we go. Huzzah. Now we have the infinite loop happening. Huzzah. Anyways, carrying on. So, my workplace, sadly, has me, working out of town, very soon. For like 2 weeks, basically, out of town. Meaning that I will not be able to do an absolute ton, and I still have to also prepare for that. Huzzah. So, what I will be doing is I will be doing another 20 pages with the C manual thing, plus the exercises. And then after that, yeah, we will be carrying on. So yeah, awesome fun times, and we'll carry on. So we're just going to sign immediately into this test. So I had the tiniest recap earlier when I was trying to timestamp the old streams. Past that, I have no heckin' idea what I will be doing. So let's do the test. Which of the following are lexical tokens? So this is something that has always bothered me on tests. Is with the terms. I always forget the terms, but I can understand the concepts, right? So if I had to guess, I'm just going to use green for this one. Actually, I'm not going to use green because green implies positive. I will use blue. Actually, no, I'll use purple because that's neutral. Which of the following are lexical tokens? So, lexical meaning like a word as far as I'm aware. So, for me, a lexical token would be like within your lexicon. So that would be like keywords, comments, white space, and then wide string constants, I believe. Actually, white space probably wouldn't be included, but That's what I would see being included. I don't know if hexadecimal would count as lexical. I could see it counting, but I'm not actually certain about that, so I guess we'll have to review. Question 2. Assuming the following strings of source characters are processed by the standard C compiler. So standard C in this case, I believe, is according to this book, is the 89 Amendment 1 revision, if I'm correct. Which of the strings would be recognized as a sequence of C tokens? How many tokens would be found in each case? Don't worry, some of those token sequences could not appear in a valid C program. Okay. So if I had to think about this, so x root 2, this is inherently a knee-jerk yes for me. So I would say that would be 1. That one is invalid because it escapes the second thingamajiggy, the little thing here. A times equals B. I don't think this one would be valid because let's just reset and go the list down, because why the heck not? Also, let me pull up cockatiel again, because cockatiel is having my messages, and I don't know where the heck the cockatiel thing is going to be hiding. Whoops. There's cockatiel. Oh, hey, look at that.
Bubshalub says, you know so much about C, yet you cannot see how insane reading this whole thing on stream is.
Perhaps we will see. This thing is testing me more than I thought, so we shall see. Anyways, so x plus plus y I don't believe would be valid, because that would be like x plus a null and r plus y, so I think that'd be invalid. Negative 12u would be unsigned, so that would immediately be failed. 1.7e plus 6l, I forget what L signifies, but I believe the E is just an exponent. Lower and uppercase counts for an exponent, so I think that would work. This string would be invalid because one of these double quotes is escaped early. String backslash... sorry, so let's see. String plus... So that plus would be escaped. Backslash double quote would be escaped. Foo backslash... Okay, so this one would be valid. That one would error. That one would error. A times equals B. We've never covered that. I know some languages would have a syntax like that, but I don't believe that would have that. And I don't believe a double pound would work for that. So now what I need to do is how many tokens would each case use? So let me just get a little pencil for that real quickly so I can do that. I guess I'll just type it. So for this one, I forget the difference, but I'm trying to signify the difference between a like string token and a other type of token. I forget what it's called, but like basically there's one variant that I remember that uses what do you call it? That uses it counts the null character, right? So like the terminating 0. So in this case, I'm going to assume that this is sort of a whole trick question thing. So I believe this would be 5. Wait, no, that's not a string, so that would be 4. Then this one over here would be... oh no, sorry, that's how many tokens it uses. So this would be 1 token because the asterisk is 1 token. Right here, this would be 1 for the E, 1 for the period, 1 for the plus, and 1 for the L. So that would be 4. And then right here, we have double quote, backslash, double quote. So that would be 4 as well. So that is what I consider to be valid. Can I make these a little bit bigger? This text is a little bit small. Let's make these like, I don't know, like 40 points. Whoop, not 470, 40. There we are. So 40, or sorry, that'd be 4. This one here I said would be 1. 1. And then this one right here would also be 4, if I'm correct. Or does it say unique, or does it say tokens in general? Okay, so it's just tokens in general. Cool. Eliminate all comments from the following C program fragment. Okay, so let's see. So if we take this and I make it wide, so I can just copy paste it. Why did that copy with 1s? That's a little weird. Let's try refix that. Okay, I don't know why there's 1s there. Backslash quote. Okay, after this asterisk, right. Okay, this copied really weird for some reason. I assume because of parsing. So it's /**, /**, double quote, star, backslash, star, back, or // whatever, star, double quote, 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 star, quote, quote, star, star, quote, star, quote. Okay, so to eliminate the comments from this, so I'm going to do a nested fashion where I work inside out. So what I'll do is I see one immediate comment right here. So there's one comment gone. Then I see another comment immediately right there. So there's another comment. And then from here, that escapes this right here. So I can see there being a comment right here that would conjoin to be a comment. Then I can see one more comment right... Oh no, because all the backslashes would escape that. Oh, I'd have to work the other way then. Shoot. Can I not Control Z this? Wow, I can't Control Z on... Wait, no I can, I think. Yeah, okay, there it is. Okay, so there we are. Okay, so we're back to it. So I'm going to work outside in this time, because I just realized technically they would be escape characters if I don't go outside in. So there's one. Actually, wait, I guess it doesn't matter now, does it? It's weird, because this is one of those things where it's like... It probably doesn't really matter until it's in program or whatever. Yeah, no, because now I'm going to have like an invalid function right there. So, yeah, let's go back. I think I was right the first time. I think I was right the first time with doing like sort of the nested thing where I focus on like the smallest possible one. So I'm like, there's another. Okay, so that backslash escapes there, which would mean that I can then delete that, and then I don't know if that technically escapes. Well, actually, no, that wouldn't escape. So that'd just be all like that. So the string should be something like that, if I'm correct. I'm probably gonna fucking bomb this terribly. A standard C compiler must perform each of the following actions as an input program. In what order are the actions performed? Okay, so must perform each action. Okay, so collect characters into tokens, remove comments, convert trigraphs. So from what I recall, I could be very wrong about this, but so if we have 1, then we have 2, and then we have finally 3 right here. So my assumption would be first they collect all characters into... No, remove comments to me makes the most sense, because the comments just can be ignored outright. So even if the comments have a trigraph in them, it makes no sense to do anything with those sections. Then I would say it would probably be convert trigraphs, because that would convert the trigraphs to characters that the humans often read. Then we'll collect characters into tokens to do things with. That makes sense to me. Let's see. Some poor choices for program identifiers here. What makes them poor choices? Okay, this one's actually pretty easy for the most part, because now I can just be an opinionated asshole. Can I not move you down? macOS, why are you weird? Really? Okay, that's dumb. Okay, well, let's just create a new one, I guess. Okay, so A, that'd be bad, formatting. nice and easy. This would be a keyword clash. Keyword clash. One or L. Or sorry, I'll say number or letter. Num or char. Then the next one is what would that one be? I'd say like over abbreviated. And then this one would be syntax plus $. Yeah, I think that'd be a good outline for what's like good or bad about it. So what from there now? Let me just make one small adjustment. There we are. Awesome. Yeah, so that would be my take for there. Write some simple code fragments in standard C that would be invalid or interpreted differently for C++, or differently in C++ for the reason listed. No dash style comments. Okay, so that would just be something along the lines of, so for A, that would be something along the lines of, say, can I format left? Left, please. There we are. Beautiful. Okay, so for A, no dash style and comment. So that would just be like int main quote code return 0. This is no op code. I'm gonna do this, and I'm just gonna break this up just so I can make it even more invalid. What did you do? Oh, I jumped down a page by accident. That's what happened. I pressed the down arrow one too many times. Why, when I hit tab, does it do that? Oh my gosh. 1, 2, 3, 4. Okay, there we are. So that's that. Let's see, type of constants. So I believe that would be using a bad name identifier, I believe. I think. No, that would be, what would that be? That would be frickin', I'm trying to remember. The issue that's been like almost 24 hours, so I don't remember everything. So type of constants would be like a data type, something like unsigned long, or sorry, it would be like const unsigned long. I'll just use the incorrect class name because screw it. I'll name it class is equal to I don't know, 49. Square root of 7. I don't know why I chose that number. I even like 7 or 49. Okay, and then from here we got C, keyword conflicts. So I'm gonna actually remove class here, and I'm just gonna say 7 squared. And then for the last one, keyword conflicts, I would do something very simple. Like I would do, what's the best example I can think of for a keyword conflict? That would be something like along the lines of like, int, or I guess it would be like enum class, is equal to, this will conflict with the C++, make that a capital C. This will conflict with the C++, keyword, class. I'm gonna actually just backslash, double quote, class, backslash, double quote. There we are. Yep, I see absolutely nothing wrong with that. So yeah, so is there an answer key? If I jump like way to the end, is there like an answer key? Oh, actually I just saw operators, so is there a times equals here? Ooh, I don't see a times equals. Oh, there's a time equals. Fuck. Alright, well I got the times equals wrong. Alright, so we got chapter answers. So, let's see. Dang, they wrote a lot more than I did. Oh, that's chapter 4. That's why it doesn't make sense. Okay, let's see if I can do this. If I snap you over here, and I open Finder, you don't need to be over there. And then I open up a Finder in a new thing. I go to my little server browser thing. Let me just do a thing. There we are. And then from here, I just want to go to my books. My books. Give me them baby back, baby back, baby back. Give me them baby back, baby back, baby back, baby them baby back, baby back, baby back. Okay, so now we have one more of these open, so now I can cross-reference. So let's just jump down to here. Oh no, sorry, wrong one. I apologize, wrong one. Do I have it saved in the wrong spot? Where's the location of you? Are you in unsorted? Are you in unsorted? Did I put you in the completely wrong spot and just didn't catch it? I did see a putty cat. Did you open a new one? You biznitch. Okay, this is gonna be a pain in the ass to like try and consult or whatever. Let's see how horribly I did though. Can I please just fucking open you in like another instance of like preview, please? Like, this is the most annoying shit when, like, applications are like, oh, I'm just gonna open over myself. I was like, no, I want fucking two of you. Like, is it that hard to grasp? Okay, so I want to jump to page, it says 531. 531. Not percentage, I don't know when I hit percentage. 531, there we are. Let's zoom you in because holy crap. Let's hide you. Can I not hide you? There we are. Okay, that's chapter 2 answers. Oh no, that's chapter 2. Okay, yeah, we're in chapter 2. Let's see. Preface, introduction. Where was the examinatory thing? Okay, so scrolling. This is important for me. This is for nobody else but me. Let's see. Okay, we're almost there. God, I did a lot of reading already. Okay, alright, let's mark up using the naughty red pen. Okay, so, out of, let's see, so, reserved words, so, hexadecimal constants is 1, wide string constants, and parentheses. Really? Comments and white spaces only, or sorry, serve only to separate tokens. Trigraphs are removed before token recognition. Okay. So I got like 1 out of 3 here. Mainly because I completely misunderstood the definition of lexical token, so that's awesome. The number of tokens for each string is, oh, okay, so I was supposed to go for every single one. Okay. I didn't actually read that fully, so let's actually go over this, and I will attempt to mark this, or not mark this, but like read this as validly as possible. So, the plus here would be 2, if I'm correct. This would be 3, because there's the minus, the U, and then the U, and then the L. Whoops, so that would be... can you fuck off with your fucking selection shit? Holy crap, you'd be 3. I said 4 for you already, so that'd be... let's see, so that'd be 1 for string, 2 for fool. Okay, so this would be 6, if I'm correct. I stand by 4. Because I'm counting like 1, 2, 3, 4, 5, 6. That would be 1 again. This would be a ternary, so that would be the double quote plus the ternary. So that would be... What would that be? That would be 1 for the ternary, 2 for the double quotes. So that'd be 2. If we're not counting if we're counting variables, all these numbers are going to be down by like at least 1. Actually, yeah, I'm gonna say 3 because there's a variable there, but I won't count numbers. That would be 3 as well. Okay, we learned a little bit by cheating that this is actually an operator, so that would be 1, 2, 3. And then right here, I don't know how that would be val, but I would see 1, 2, 3, 4, 5. Oh no, so that's while do. So that would be 2 separate tokens right there, because while hashtag and then hashtag do is 2 separate tokens. So that to me makes sense. Where did Art go with the answer key? Okay. So now that I actually understood the statement semi-correctly. Oh, I realized I opened it in Firefox. Huzzah. Wait, let's see. It was 531 if I'm correct. Yeah, so let's just jump down to 531. Okay, so A we got wrong. Yeah, I can actually see that one. I don't know why I wrote 2. 3 makes sense because I was counting the variables. I don't know what I was actually thinking there. I don't know why. Yeah, I don't know what I was fucking thinking there. Holy shit. Sorry, I'm just looking at that stupid. I'm just like, what? So that one's wrong. 2. Minus is an operator, not part of the constant. Okay. So that one's 2. 3. C is 1. Really? Oh my god, I hate fucking GUIs sometimes. So that's 1. That looks like a 2, but whatever. Good enough. Actually, I'm gonna try to fix that, because holy crap. Yeah, there we are. D is going to be 3 tokens. The second one is quote foo. Okay, so they're counting the double quotes as, like, everything within the double quotes as, what do you call it? As, actually, no, wait. How did I count this one again? It was 1, 2, 3, 4, I think is how I did it. Because that plus would be ignored. So, 3 tokens, the second one is foo. So, first token, second token, third token. I fail to see how the middle foo becomes a token. Is that because the compiler just basically abstracts what's in between here? That's weird. I'm just gonna put a little note here for page 5, 3, 1. Okay, carrying on. E is 1 token. That is... Wait, no, wait. D... Yeah, okay, this is 1 token for some reason. Is it... Yeah, no, that'd be 1 token because the entire string gets abstracted. So, okay, so a string counts as a whole token. I was reading those slightly wrong. Alright, x times 2 is 4 tokens. X, really, 4. X... Oh, sorry, times is not a single operator. That's weird. Okay, and the number does count as an operator, I guess? So that's all 1 number, so that would be extracted. Okay, I see. And then the letters only signify the type of data, not the actual representation of the data. Okay, I think that makes sense. Wait, so looking at this one now, this G is probably going to be 1. Not a token, the same as X backslash, which is undetermined string constant. Okay, so Even then I was wrong. So that would be, I'll just say 0. H, I still don't know what that'd be. Not a token. 0. Okay, I would be 3, as times equals is an operator. So I got 1. I got 1 out of fucking 10. And then do while either none or 3. What? Pound pound is not a lexical token, but happens to be a preprocessor token. Okay. So I'll just say 0 or 3. That is a very bad line. Okay, so I got 1 out of 10. Awesome. This is why we read and we learn. Okay. The result is that. Okay, I was off. Why the heck is that? This is going to be star, 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 / comma. The comments are identified next between parentheses. Quotation marks inside a comment do not have to balance. Okay, so I see that, I see that, I see that. Okay, I can kind of see it. Okay, so it only cared about... Okay, I think this was a misconception of mine. With this, I was not reading it as do what the compiler would do. I was just reading it as, like, do what the human might do. So that's where my confusion was, I would argue. Yeah, that's kind of it, I guess. Oh, there's a 4 down here. That makes more sense. So, let's see how I was even close. So, no. Okay, so... so that one's wrong. That one's wrong. Is collecting characters correct? Nope. So 3 is also wrong. Whoops. 3 is also wrong, and then 4 is just going to be inherently wrong. I didn't realize there was a 4 down there, haha. So it would be in order. I don't want a text box there, I want a text box up here, please. Sure. I want to make you frickin' another color. I'm gonna make you the angry red. I'm gonna say oh my god, fuck off. 1 dot convert, 2 dot processing line continuation. 3 dot removing comments. As far as how late that is. 4 dot collecting characters into tokens. Okay. Let's see. So let's see what 5 says. 5 is the only one that I'm feeling like okay about now. So that's awesome. Let's see. So some possible objections. Difficulty to read. The multiple words in the identifier. Yeah, okay, so I'd say that one's correct. The identifier's spelling is close to a reserved word. Yeah, I'm gonna say that's close enough. Like, keyword clash and being too close. That's the same thing. C, lowercase L and uppercase O are easily mistaken for 1 and 0. Yep. So that was more or less my thing there that I said. D, closely resembles a numerical literal. The first character is an O. Okay, so I'm gonna say no on that one. And then E is going to be if a compiler accepted this identifier, it would be an extension. Okay, so that is also wrong. So I got out here like 3 out of 5. There we are. Let's see. let's see. For this compiler identifier, it would be, or sorry, no. So A would be, I don't know. I'm gonna say maybe. I'll take it as a win or a loss depending on which ones I'm on the opposite side of. For B, this is in question 6, right? Yeah, for B, what? I have no idea how to even evaluate what they're saying. Assuming a C standard implementation that distinguishes only the first 31 characters, the first 31 characters of identifiers, a standard C program that spelled the same identifier differently after the 31st character would be flagged as an error in C++. Okay, so I'm gonna say an X there, and then I don't even see a D here, so I'm gonna take no responsibility for that last one. I'm gonna say it's out of 3. C would be an example, the declaration. Yep, okay, that one I basically freaking nailed right on the head. That's a very firm check mark. So I don't see a D. I'm just gonna say 2 out of 3. I see the top one as more valid than not. So heckin' take it. So out of all of this, I got, let's see, so we got 13, 18, 21. So out of 21, I got 5, 6, 7 right. I'm a 33% student. Huzzah. Well, that's depressing. I guess I'll roll forward. Because I ain't going to get any better if I don't practice. So, let us begin with today's lesson thingy. Yeah, okay. I had that marked. I just want to make sure that was marked. That's all. That's all. That's all. That's all. Leave me alone. That's all. That's all. Leave me alone. I'm going to get a sippy. I'm going to get a sippy and you can't stop me. Okay. Here we go. Part 3. The C preprocessor. The C preprocessor is a simple macro preprocessor that conceptually poses the same source text of a C program before the compiler reads the source program. In some implementations of C, the preprocessor is actually a separate program that reads the original source file and writes a new preprocessed source file that can then be used as an input to the C compiler. In other implementations, a single program performs the preprocessing and compilation in a single pass over the source file. 3.1 Preprocessor commands. The preprocessor is controlled by a special preprocessor command lines, which are lines of the source file beginning with the character pound. Lines that do not contain preprocessor commands are called lines of the source program text. The preprocessor commands are shown in table 3-1. The preprocessor typically removes all of the preprocessor command lines from the source file and makes the additional transforms in the source file as directed by the commands, such as expanding macro calls that order within the source program text. The resulting preprocessed source text must be a valid C program. The syntax of the preprocessor command is completely independent of left parenthesis, although in some similar way to right parenthesis, the syntax of the rest of the C language. For example, it is possible for a macro definition to expand into a syntactically incomplete fragment as long as the fragment makes sense. Left parenthesis, i.e., is properly completed. Right parenthesis. In all contexts in which the macro is called. Table. I will read this table. However, I will put as a warning if I have like a sort of multi-state table like before, then I'm just going to sort of just skip it. So I'm just going to read the macros so we can kind of chip through it fluidly. So table 3-1 preprocessor commands, table header command, hashtag defined, define, meaning define a preprocessor macro, section 3.3. Hashtag undef, UNDEF, meaning remove a preprocessor macro definition, section 3.3.5. pound include, table header command, pound include, meaning insert text from another source file, section 3.4. Table header command, pound if, meaning conditionally include some text based on the value of a constant expression, section 3.5.1. Hashtag ifdef, ifdef, meaning conditionally includes some text based on whether a macro name is defined, section 3.5.3. Command, pound else, meaning alternatively include some text of the previous pound if, comma, pound if def, comma, pound if in ndef, or pound elif test failed 3.5.1. I'm jumping up one because dyslexia missed the if ndef above. Table header pound if ndef, ifndef, meaning conditionally includes some text with the sense of the test opposite of that. Oh my gosh. Conditionally includes some text with the sense of the test opposite that of pound if def. Section 3.5.3. Skipping over the if, back to the following one. Pound endif, endif, meaning terminate conditional text. Section 3.5.1. Command pound line, meaning supply a line number for compiler messages. Section 3.6. Command pound elif, elif, superscript a, alternatively include some text based on the value of another constant expression if the previous pound if, comma, pound if def, comma, pound if ndef, comma, or pound elif test failed. Section 3.5.2. Command defined, superscript a, preprocessor function that yields preprocessor function that yields 1 if a name is defined as a preprocessor macro and 0 otherwise. Used in pound if and pound elif. Section 3.5.5. Command pound operator superscript b, meaning preprocessor function that yields 1 if the name is defined as a preprocessor macro and 0 otherwise. Used in pound if and pound elif. Section 3.5.5. Command pound operator superscript b, meaning replace a macro parameter with a string constant containing the parameter's value. Section 3.3.8. Oh, sorry, 3.3.9. My apologies. Command hashtag pragma superscript b, meaning specify implementation dependent information to the compiler. Section 3.7. Pound error superscript b, meaning produce a compile time error with a designated message. Section 3.8. Definitions of superscript a, not originally part of C, but now common in ISO and non-ISO implementations. Superscript b, new in standard C. I'm going to mute for a second because my work is calling. Apologies, work is paying my bills, so alas, I need to rely on work for work-related things. Ha ha ha. Anywho, we can carry on with the manual now. I apologize for the interruption. Also, little side thing is if you're interested in engaging, feel free to use the command bang TTS and then type whatever the heck you want in chat. And the little bot, I will read it at the end of the section. So, hey, feel free to if you want to. No pressure, but there you go if you want it. Isn't that right, Tib? Yeah, that's right. You stay silent, you little bitch. Okay. 3.2, preprocessor lexical conventions. The fat tongue. Let me adjust one small thing, sorry. The preprocessor does not parse the source text, but it does break it up into tokens for the purpose of locating macro calls. The lexical conventions of the preprocessor are somewhat different from the compiler proper. The preprocessor recognizes the normal C tokens and additionally recognizes them as tokens. Other characters that would not be recognized as valid C proper, as valid in C proper, my apologies. This enables the preprocessor to recognize file names, the presence and absence of white space, and location of end-of-line markers. The line beginning with pound is treated as a preprocessor command. The name of the command must follow the pound character. Standard C permits white space to precede the following, Standard C permits white space to precede and follow the pound character in the same source line, but some older compilers do not. A line whose only white space character is a pound is termed a null directive. In standard C, it is treated the same as a blank line. Older implementations may behave differently. The remainder of the following... Frick, I don't know why my dyslexia is like... The remainder of the line following the command may contain arguments for the command if appropriate. If a preprocessor command takes no arguments, then the remainder of the command line will be empty except perhaps those for whitespace characters or comments. Many pre-ISO compilers silently ignore all characters following the expected arguments, left parenthesis, if any, right parenthesis. This can lead to probability problems. The arguments to the preprocessor are generally subject to macro replacement. Preprocessor lines are recognized before macro expression. Therefore, if a macro expression expands into something that looks like a preprocessor command, that command will not be recognized by the preprocessors in standard C or in other C compilers. Left parentheses, some older Unix implementations violate this rule, right parenthesis. Example. The result of the following code is not to include the file math.h in the program being compiled. Begin comment. This example doesn't work as one might think. End comment. Hashtag define. Get math. Pound include. Left angled bracket. Math.h. Right angled bracket. Get math. Instead, the expanded token sequence. Pound include. Left angle bracket. Math.h. Right angle bracket. Is merely passed through and compiled as left parenthesis, erroneous, right parenthesis, C code. As noted in section 2.1.2, all source lines, left parenthesis, including preprocessor commands, right parenthesis, can be continued by preceding the end-of-line marker by a backslash character. This happens before scanning for preprocessor commands. Example. The preprocessor command pound define, error, left parenthesis, flag, comma, message, right parenthesis, if, left parenthesis, flag, right parenthesis, backslash, printf, left parenthesis, msg, right parenthesis, is the same as pound define, error, left parenthesis, flag, comma, message, right parenthesis, if, left parenthesis, flag, right parenthesis, printf, left parenthesis, msg, right parenthesis. If the backslash character below immediately precedes the end-of-line marker, these two lines, hashtag define, backslash the character, hashtag define asterisk, asterisk character will be treated as the same preprocessor command. Hashtag define backslash hashtag define asterisk character. As explained in section 2.2, the preprocessor treats comments as a white space, and line breaks within commas do not terminate preprocessor commands. As explained in section 2.2, the preprocessor treats comments as white space, and line breaks within commas do not terminate proper preprocessor commands. References: comments 2.2, line termination and continuation 2.1, tokens 2.3. Now I noticed there were some messages sent, so I'll take a brief little peek at those real quickly, and we'll see. Your dedication to this scares me. I mean, hey, Bubs, if you ever thought that I was weak-willed, then there we go. Also, I will push this.
User Budgeshalad says banner.
There you go, Tib. Way to slide in there, smooth as butter. Away. Smiley. Cat face. Also, hello, Neo... Heliops? I don't know how to say your name. I apologize. What I will do is I will drag Cockatiel over here, I will highlight your name and say you, and simply refer to you as Neo. Because, holy heck, I brain small and squishy, I will put it that way. But yes, hello, Catface. Hi. Fun times, isn't it? Let's carry on, I suppose. 3.3. Definition and replacement. The hashtag define preprocessor commands causes a name, left parenthesis, identifier, right parenthesis, to become defined as a macro to the preprocessor. A sequence of token called the body of the macro is associated with the name. When the name of a macro is recognized in the program source text or the arguments of a certain other preprocessor commands, it is treated as a call to that macro. The name is effectively replaced by a copy of the body. If the name is defined to accept arguments, then the actual arguments following the macro name are substituted for formal parameters in the macro body. Example: if a macro sum with two arguments is defined by pound defined sum left parenthesis x comma y right parenthesis x plus y, then the preprocessor replaces the source program line result equals sum left parenthesis 5 comma a times b right parenthesis semicolon with the simple left parenthesis and perhaps unintended right parenthesis text substitution result equals 5 plus a times b comma or semicolon. Since the preprocessor does not distinguish reversed words from other identifiers, it is possible, in principle, to use a C reversed word as the name of a preprocessor macro, but to do so is usually a bad programming practice. Macro names are never recognized within comments, string, or character constants, or hashtag include file names. Okay, I'm gonna take a little sippy. Okay. Carrying on. 3.3.1 Object-like macro definitions. The pound define command has two forms depending on whether it is a left parenthesis immediately, if a left parenthesis immediately follows the name to be defined. The simpler object-like form, I was expecting something else to be there. The simpler object-like form has no left parentheses. Pound define, name, sequence of tokens, subscript opt. An object-like macro takes no arguments, but is invoked merely by mentioning its name. When the name is encountered in source program text, the name is replaced by the body, left parenthesis, the associated sequence of tokens, which may be empty, right parenthesis. The syntax of pound define command does not require an equal sign or any other special delimiter token after the name being defined. The body starts right after the name. The object-like macro is particularly useful for introducing named constants into a program so that a, quote, magic number, unquote, such as the length of a table may be written in exactly one place and referred to elsewhere by name. This makes it easier to change the number later. Another important use of object-like macros is to isolate implementation-dependent restrictions on the names of externally named definitions and variables. An example of this appears in section 2.5. Example. Here are some typical macro definitions. Pound define block underscore size 0x100. Pound define track underscore size left parenthesis 16 times block underscore size right parenthesis. Pound defined EOT apostrophe backslash 004 apostrophe. Pound define error message quote triple asterisk error %d colon %s period new line unquote. A common programming error is to include an extraneous equal sign. Pound define number underscore of underscore tape underscore drives equals 5. Comment begin, probably wrong, end comment. This is a valid definition, but causes the name number underscore of underscore tape underscore drives to be defined as quote equals 5 unquote rather than 5 than as 5. Apologies. If one were to write the code fragment if left parenthesis count not equal number underscore of underscore tape underscore drives right parenthesis ellipses, it would be expanded to if left parenthesis count not equals 5 right parenthesis. That was not equals. There's two equal signs there. Ellipses. Which is syntactically invalid for similar reasons. Also be careful to avoid extraneous semicolons. An extraneous semicolon. Pound define number underscore of underscore tape underscore drives 5 semicolon. Comment begin, probably wrong, end comment. References. Compound assignment operators 7.9.2. Operators and separators 2.4.
I'm gonna take another sippy.
Okay. Rolling forward. 3.3.2. Defining macros with parameters.
Parameters.
For more complex function-like macro definition, declares the names of formal parameters within parentheses separated by commas. That read really weird to me. Pound define name left parenthesis identifier dash list subscript opt right parenthesis sequence dash of dash tokens subscript opt, where identifier dash list is a comma separated list of formal parameter names. In C99, an ellipses left parenthesis 3 periods semicolon 3 periods, aka the ellipses symbol, right parenthesis, may also appear after identifier dash list to indicate a variable arguments list. This is discussed in section 3.3.10. Until then, we consider only fixed argument lists. The left parentheses must immediately follow the name of the macro with no intervening white space. Sorry, that read weird for me again. I apologize. If white space separates the left parentheses from the macro name, the definition is considered to define a macro that takes no arguments and has a body beginning with a left parentheses. The names of the formal parameters must be identifiers, not two the same. There is no requirement that any of the parameter names be mentioned in the body, left parenthesis, although normally they are all mentioned, right parenthesis. A function like macro can have an empty formal parameter list, left parenthesis, i.e. 0 formal parameters, right parenthesis. This kind of macro is useful to simulate a function that takes no arguments. A function like macro takes as many arguments as there are formal parameters. The macro is invoked by writing its name, a left parentheses, then one actual argument token sequence for each formal parameter, then the right parentheses. The actual argument token sequences are separated by commas, left parenthesis. When a functioning like macro with no formal parameters is invoked, an empty actual argument list must be provided. Sorry, that accidental highlight is bothering me. Right parenthesis. When a macro is invoked, white space may appear between the macro name and the left parentheses are the actual arguments. Left parentheses, some older and deficient preprocessor implementations do not permit an actual argument token list to extend across multiple lines unless the lines do be continued with a backslash. Right parenthesis. An actual argument token sequence may contain parentheses if they are properly nested or balanced. And it may contain commas if each comma appears within a set of parentheses. Left parenthesis. This restriction prevents confusion with the commas that separate the actual arguments. Right parentheses. Parenthesis. Braces and subscripting brackets likewise may appear within macro arguments, but they cannot contain commas and do not have to balance. Parentheses and commas appearing within character-constant and string-constant tokens are not counted in the balancing of parentheses and delimiting of actual arguments. In C99, arguments to a macro can be empty, that is, consistent of no tokens. Example. Here's the definition of a macro that multiplies as two arguments. Pound define, product, left parenthesis, x comma y, right parenthesis, left parenthesis, x, right parenthesis, asterisk, left parenthesis, y, right parenthesis, right parenthesis. It is invoked twice in the following statement. X equals product, left parenthesis, a plus 3, comma, b, right parenthesis, plus, product, left parenthesis, c, comma, d, right parenthesis, semicolon. The arguments to the product macro could be a function, left parenthesis, or macro, right parenthesis, calls. The commas within the function argument list also do not affect the parsing of the macro arguments. Return, product, left parenthesis, f, left parenthesis, a comma b, right parenthesis, comma, g, left parenthesis, a comma b, right parenthesis, semicolon, comment block begin, okay, right parenthesis, or end comment block. My apologies, not right parenthesis. Example. The getChar macro has an empty parameter list. Hashtag define, getChar, left right parenthesis, getC, left parenthesis, std in, right parenthesis, also known as standard in. When it is invoked, an empty argument list is provided. While, left parenthesis, c equals getChar, left right parenthesis, not equals EOF, right parentheses, ellipses, left parenthesis, getChar, comma, standard in, comma, and EOF, I'm going to say EOF instead of EOF from now on, EOF are defining the standard header, standard.io.h, right parenthesis. Example. We can define a macro that takes in its arguments as an arbitrary statement. Pound define, insert, left parentheses, statement, right parenthesis, statement. The invocation, insert, left parenthesis, left squirrely bracket, a equals 1, semicolon, b equals 1, semicolon, right squirrely bracket, right parenthesis, works properly, but if we change the two assignment statements to a single statement containing two assignments expressions, insert, left parenthesis, left squirrely bracket, a equals 1, comma, b equals 1, semicolon, right squirrely bracket, right parentheses, then the preprocessor will complain that we have too many arguments, too many macro arguments for insert. To fix the problem, we would have to write insert, left parenthesis, left squirrely bracket, left parenthesis, a equals 1, comma, b equals 1, right parenthesis, semicolon, right squirrely bracket, right parenthesis. Example, defining function-like macros to be used in a statement context can be tricky. The following macro swaps the values of two arguments, x and y, which are assumed to be of a type whose values can be converted to unsigned long and back without change, and do not involve the identifier underscore temp. Hashtag define, swap, left parenthesis, x comma y, right parenthesis, left scrolly bracket, unsigned long, underscore temp equals x, semicolon, x equals y, semicolon, y equals underscore temp, semicolon, right scrolly bracket. The problem is that it is natural to want to place a semicolon after swap as if you were, as you would if swap were a function. If, left parenthesis, x is greater than y, right parenthesis, swap, left parenthesis, x comma y, right parenthesis, semicolon, comment start, whoops, comma end, else, x equals y, semicolon. This will result in an error since the expansion includes an extra semicolon, left parenthesis, section 8.1, right parenthesis. We put the expanded statements on a separate lines to illustrate the problem more clearly. If, left parenthesis, x is greater than y, right parenthesis, left scrolly bracket, unsigned long, underscore temp equals x, semicolon, x equals y, semicolon, y equals underscore temp, semicolon, right scrolly bracket, new line, semicolon, else x equals y, semicolon. A clever way to avoid the problem is to define the macro body as a do-while statement, which consumes the semicolon. Left parenthesis, section 8.6.2, right parenthesis, pound define, swap, left parenthesis, x comma y, right parenthesis, backslash, do, left scrolly bracket, unsigned long, underscore temp equals x, semicolon, x equals y, semicolon, y equals underscore temp, semicolon, right scrolly bracket, while, left parenthesis, 0, right scrolly bracket. While a function-like macro call is encountered, the entire macro call is replaced after parameter processing. By a process copy of the body, parameter processing proceeds as follows. An actual argument token strings are associated with the corresponding formal parameter names. A copy of the body is made in which every occurrence of a formal parameter name is replaced by a copy of the actual argument token sequence associated within it. This copy of the body then replaces the macro call. The entire process of replacing a macro call with the processed copy of its body is called macro expansion. The process copy of the body is called the expansion of the macro call. Example. Consider this macro definition, which provides a convenient way to make a loop that counts from a given value up, left parenthesis, and including, right parenthesis, sum limit. Pound define incr, I will read that as increment, left parenthesis, v, comma, low, comma, high, right parenthesis, backslash, new line, for left parenthesis, v, right parenthesis, equals left parenthesis, low, right parenthesis, semicolon, left parenthesis, v, right parenthesis, less than or equal to, left parenthesis, high, right parenthesis, semicolon, left parenthesis, v, right parenthesis, plus, right parenthesis. To print a table of cubes from the integers from 1 to 20, we could write pound include left square bracket or left angled bracket standard io.h right parenthesis int main left parenthesis void right parenthesis left scrolly bracket int j semicolon increment left parenthesis j comma 1 I believe comma 20 right parenthesis new line print f left parenthesis quote percent sign 2d percent sign 6d backslash n aka new line unquote comma j asterisk j right parenthesis, semicolon, return 0, semicolon, right curly bracket. To call the macro increment is expanded to produce this loop. For left parenthesis, j, right parenthesis equals left parenthesis 1, right parenthesis, semicolon, left parenthesis j, right parenthesis, less than or equal to left parenthesis 20, right parenthesis, comma, left parenthesis j, right parenthesis, plus, right parenthesis. The liberal use of parentheses ensures that complicated actual arguments are not misinterpreted by the compiler. Left parenthesis, see section 3.3.6, right parenthesis, refers do statement 8.6.2, statement syntax 8.1, unsigned long 5.1.2, white space 2.1.2. Okay. We have done it. I'm gonna take a small break here to read chat because I wasn't trying to ignore you. I'm trying to do sections in like a cluster. Because holy crap, that's a pain in the actual behukum. So awesome. Get that cringe out, asterisk. I fail to receive what you're referring to. What is this section about? This section is effectively talking about like macros in C and how they're defined and all that other crap. So it's basically talking about, like what macros are, some semi-common uses for them, things along that nature. I will confess at this point, I am currently a little confused for the use of a macro because I believe I recall reading that a macro doesn't go across like header files. So if you import as a header file, then it's just a huge ass mess. I love C. Java, on the other hand, needs to find the gate to hell. I have heard a lot of people say that, and I'm kind of inclined to agree. It's actually kind of funny, because from my perspective, Java's supposed to be the whole, write once, run everywhere, but that's actually been taken over by JavaScript, funnily enough, so that's neat. Bub Shalub says, I just beat Half-Life 1. I have officially beat every Half-Life game. Very epic. Oh. I'm eating some popcorn because I'm making poor life decisions because this is my dinner. And then after I take probably one more bite or what have you, I will probably go back into slamming macro shit because, yeah, I'm fun like that. I'm actually going to change one more thing while I'm at 2. Let me go here. There we are. Adam, I don't see any deleted messages. There might be an issue with YouTube log. Oh yeah, no, there's definitely an issue with YouTube. I have experienced many times this issue of people saying they sent something and they just haven't sent it. From what I've heard, YouTube chat is kind of a garbage fire or a dumpster fire or whatever, but the other issue is that like YouTube doesn't seem to be fucked to fix it. And that's a whole other wonderful thing. Poor life decisions, ignores the facts. He's reading the C manual while being a 3D furry model. Hey, I'm 2D, actually. I'm 2D. I got no depth. Look at my ears. Look at my ears. They got no depth. I am a flat man. Or flat boy. Flat fluffy. Shh. No, you shh. I will not be shh. You are the one who will be shh. Shh. It's a library. Let me just close that real quickly. Okay. Alright. I'm going to do another read statement, and I'll check chat in a second once I'm done this next little section, so pray for me. 3.3.3, rescanning of macro expressions. Once a macro call has been expanded, the scan for macro calls resumes at the beginning of the expansion so that the names of macros may be recognized within the expansion for the purpose of further defining macro replacement. Macro replacement is not performed on any part of a #define command, not even the body. At the same time, the command is processed and the macro name defined. Macro names are recognized within the body only after the body has been expanded for some particular macro call. Macro placement is also not performed within the actual argument token strings of a function like macro call at the time. Oh my gosh, I don't know why I highlighted that. Undo that, please. Sorry, a function like macro call at the time the macro call is being scanned. Macro names are recognized with actual argument token strings only during the rescanning of the expansion. Assuming that the corresponding formal parameter, in fact, occurred one or more times within the body, left parenthesis, thereby causing the actual argument token string to appear one or more times in the expansion, right parenthesis. Example, given the following definitions, pound define plus left parenthesis x comma y right parenthesis add left parenthesis y comma x right parenthesis pound define add left parenthesis x comma y right parenthesis left parenthesis x right parenthesis plus left parenthesis y right parenthesis. The invocation plus left parenthesis plus left parenthesis a comma b right parenthesis comma c right parenthesis is expanded as shown next. Step, this is a table. It's going step then result a b. I'll just read them in order. 1 dot original plus left parenthesis a comma b right parenthesis comma c right parenthesis. Step 2, add left parenthesis c comma plus left parenthesis a comma b right parenthesis 3, left parenthesis c right parenthesis plus left parenthesis a comma b right parenthesis 4, step 4, left parenthesis c plus left parenthesis add left parenthesis b comma a right parenthesis. Fifth and final step, left parenthesis c right parenthesis plus left parenthesis b right parenthesis plus symbol right parenthesis. I apologize there. I used plus interchangeably with the symbol, so I apologize. Step 4 and 5 was basically exclusively the plus symbol. And then step 2 and above was exclusively macros for plus. Macros appearing in their own expansion, either immediately or through some indeterminate sequence of nested macro expansions, are not re-expanded in standard C. This permits a programmer to redefine a function in terms of its old function. Older C preprocessors traditionally do not detect this recursion, and will attempt to continue the expansion until they are stopped by some system error. Example. The following macro changes the definition of the square root function to handle negative arguments in a different fashion than is normal. Pound define square root left parenthesis x right parenthesis left parenthesis x right parenthesis less than 0 question mark square root left parenthesis negative left parenthesis x right parenthesis semicolon square root left parenthesis x. That's a ternary. I apologize. Let's see. So whatever. I'm just gonna keep going. Colon square root left parenthesis x right parenthesis. That can effectively read if x is less than 0. Square root returns negative x. Else it will return square root. The square root of x. Except that evaluates its argument more than once. This macro would work as intended in standard C, but might cause an error in older compilers. Similarly, pound define cha unassigned char. See section 7.4.3 for an interesting example of using a macro for trace function calls. Holy crap, that was a pain in the ass. Real quickly, let me respond to a message because I have work harassing me right now for fun. Um, there we go. Doobloop. Alright, there's that. Where are we going from here? Oh yeah, Bub said something. Here, you know what? I don't want to read Tib. Oh, wrong thing. Let us swap you out for, Tib. Tib the toaster, I'm gonna make you say this.
Budgeshalub says, Lumeo, I watched a video about the fall of Quiznos, and one of the things that made it take a huge hit was Subway putting toasters in their stores.
Yeah, I mean, there's a lot of reasons why I think Quiznos sort of fell apart, so to say. My main issue is that, like, Quiznos and Subways both always fell into, like, a soft food, or sorry, not no soft food, a fast food, a fast food angle. So the issue is that, sorry, I'm just responding to more job stuff because it's... Alright, there's that. Sorry, like, I'm, like, the boss is, like, trying to get, like, my, like, coworker to, like, communicate to me about, like, start times and shit, and I'm just sitting here like, I don't fucking know! Like, dude, I don't know, fucking, it's so stupid. My god, like, I fucking hate my current job, and man, if I could switch into programming, I would fucking nut. Fin a nut. That's all I can say. Quiznos corporate found it was more profitable to force their franchises to buy their own, to buy from their own supplier at extremely high rates. Yeah, I actually think I know the video you're talking about. For those who are kind of unaware of the context, I believe what it basically was that if you bought a Quiznos store, you were effectively forced to only source your, I believe, ingredients and possibly, like, building materials for, like, the restaurant from a single source. So, like, if you, like, let's say, like, as an example, you want to buy lettuce, I think, you couldn't buy lettuce from, like, anybody. You had to buy lettuce from, like, Quiznos authorized retailer, and because they had, like, an exclusivity contract with them, the Quiznos exclusive retailer or whatever, they would effectively be forced to pay, like, extortionary rates, like multiple times more than what was average in some cases. And this actually led to multiple of the franchisors actually like suing Quiznos themselves. I'm just gonna let Tib read this.
User Budgeshalub says, stay out of my recommended feed, you gremlin equals.
No, this is my recommended feed, and also I'm pretty sure that video is like 3 years old. It's not new, I can promise you that. Anywho, let us wiggle forward. 3.3.4 predefined macros. Preprocessors for standard C are required to define certain object-like macros, left parenthesis table 3-2, right parenthesis. The name of each begins and ends with 2 underscore characters. None of these predefined macros may be undefined, left parenthesis, pound undef, right parenthesis, are refined by the programmer. The underscore line underscore and underscore file underscore macros are useful when printing certain kinds of error messages. The underscore date underscore and underscore time underscore macros can be used to record a compilation when a compilation occurred. The values of underscore time underscore and date underscore remain constant throughout the compilation. The values of the underscore line underscore and underscore file underscore macros are established by the implementation, but are subject to alteration by the pound line directive. left parenthesis, section 3.6, right parenthesis, the C99 predefined identifier underscore func underscore left parenthesis, section 2.6.1, right parenthesis, is similar in purpose to underscore line underscore, but is actually a block scope variable, not a macro. It supplies the name of the enclosing function, the underscore stdc underscore and underscore stdc underscore stdc underscore version underscore macros are useful for writing code compatible with standard and non-standard C implementations. The underscore stdc underscore hosted underscore macro was introduced in C99 to distinguish hosted from freestanding implementations. The remaining C99 macros indicate whether the implementation just cuts off there. Oh, it jumped over, sorry. The remaining C99 macros indicate whether the implementation's floating point and wide character facilities adhere to other relevant international standards. Left parenthesis, adherence is recommended but not required. Right parenthesis. Above is the table. I'm going to read it. This is going to be very fun, so that's epic. And basically it's just talking about the predefined macro, so here we go. Macro underscore line underscore superscript A value, the line number of the current source program, line expressed as a decimal integer constant, underscore file underscore superscript A, the name of the current source file expressed as a string constant, underscore date underscore the calendar date of the translation expressed as a string constant of the form MMM DD YYYY. MMM is as produced by ASC time. Period. That's all one word, by the way. Like, there's no spacing or underscores. Macro underscore time underscore. The time of the translation expressed as a string constant of the form HH MM SS as returned by ASC time. ASC time. I'm assuming that's supposed to be async time or something similar to that. Underscore STDC underscore the decimal constant of 1 if and only if the compiler is an ISO conforming implementation. Underscore STDC underscore version underscore if the implementation conforms to amendment 1 of C89, then this macro has the value 199409L. If the implementation conforms to C99, then the macro has a value of 199901L. Otherwise, its value is not defined. Underscore STDC underscore hosted underscore C99, defined as 1 if the implementation has a hosted implementation, 0 if it has a freestanding implementation. Underscore STDC underscore Ike underscore 559 C99, defined as 1 if the floating point implementation conforms to Ike 60559, otherwise undefined. Underscore STDC underscore Ike underscore 559 underscore complex underscore C99, defined as 1 if the complex arithmetic implementation conforms to the Ike 60559, otherwise undefined. Underscore STDC underscore ISO underscore 10646 underscore C99, defined as a long integer constant YYYYMM capital L to signify that WCHAR underscore T values adhere to ISO 10646 standard with corrections and amendments as the given year and month. Otherwise undefined. Superscript A. These macros are common in non-ISO implementations also.
Now I take a sippy.
Implementations routinely define additional macros to communicate information about the environment, such as the type of computer for which the program is being compiled, exactly which macros are defined as defined is implementation dependent. Oh my gosh, I'm rereading that. Sorry. Exactly which macros are defined is implementation dependent, although Unix implementations clearly predefine Unix. Unlike the built-in macros, these macros may be undefined. Standard C requires implementation-specific macro names to begin with a leading underscore followed by either an uppercase letter or an underscore. Another underscore, sorry. Left parenthesis, the macro Unix does not meet that saturation? Citeron? I don't know how to say that word. I apologize. Right parenthesis. Example, if predefined macros are useful in certain kinds of error messages, I'm going to scroll up behind it. If, left parenthesis, n is not equal to m, right parenthesis, f print f, left parenthesis, standard error, comma, quote, international error, colon, line %d, comma, file, %s, new line, unquote, comma, underscore, line, underscore, comma, underscore, file, underscore, right parenthesis, semicolon. When I said percent there, that's the percent symbol, and moving forward, that is what I will be, and hopefully I will specify if it is something else. Pound if def, underscore, win32, comment begin, code for win32 environment, end comment, pound ndef, if the underscore stdc underscore and underscore stdc underscore version underscore macros are useful when writing programs that must adapt to both standard and non-standard implementations. Pound if def underscore stdc underscore comment begin some version of standard C, end comment, pound if defined left parenthesis underscore stdc underscore version underscore right parenthesis. I'm gonna start reading that as standard C instead of stdc. Ampersand, aka and, which I will read in the future. Underscore standard C underscore version underscore less than or equal to 1999-01L. Comment begin C99 end comment. Pound elif defined left parenthesis underscore standard C underscore version underscore right parenthesis and underscore standard C underscore version underscore is less than or equal to 1994 09L. Comment begin C89 amendment 1 right parenthesis else comment begin C89 but not amendment 1 end comment end if else comment begin underscore standard C underscore not defined end comment begin not standard C end comment pound end if refers ASC time facility 20.3 complex arithmetic chapter 23 fprintf 15.11 freestanding and hosted implementations 1.4 pound if def preprocessor command 3.5.3 pound if preprocessor command 3.5.1 undefining macros 3.3.5 wchar underscore t 24.1. There is the end of the subchapter thing. So hello once again, chat. Let us see what the heck you're all saying, because I am the very epic at reading chat, because I am an absolute wizard of chat reading. That is right, me. I am an expert. What are you going to do about it? Huh? That's right, none. None, that's what I thought. Absolutely none. Let's see. I'm gonna make Tib say this. Have fun, Tib.
User Budgeshalub says, lick nuts.
So tell me, Tib, are you proud that I made you read that? Is that your like defining moment? There we go. Okay. Well, thank you, Tib. Appreciate it. Well, I guess I will keep rolling with the funky little dice that I got rolling, and we'll slam on through. Okay. Ooh, kind of a large chapter. Kind of, not really. 3.3.5, undefining and redefining macros. The %undef, which I will now read as undefined, command can be used to make a name no longer defined. Undefined name. I think I must keep saying undef, actually. Undef name. This command causes the preprocessor to forget any macro definition of name. It is not an error to undefine the name currently not defined. Once a name has been undefined, it may then be given a completely new function, left parenthesis, using #define, right parenthesis, without error. Macro replacement is not performed within undef commands. The benning, I think it's supposed to be beginning. No, the benning definition of a macro is allowed in standard C and other implementations. That is, a macro may be redefined if the new situation is the same, token for token, as the existing function. The redefinition must include white space in the same locations as the original definition, although the particular white space characters can also be different. We think programmers should avoid depending on benning. Benning, that's such a weird word to me. I've never seen that before. Benning redefinitions. It is generally better style to have a single point of definitions for all kind of entities, including macros. Left parenthesis, some older implementations of C may not allow any kind of redefinition. Right parenthesis. Example. In the following definitions, the redefinition of null is allowed, but neither redefinition of func is valid. Left parenthesis. The first includes white space, not in the original definition, and the second changes two tokens. Right parenthesis. %define null equals 0, or sorry, pound, not percent. Define null 0. Define func, left parenthesis, x, right parenthesis, x plus 4. Define null, begin comment, null pointer, right end comment, 0. Define func, left parenthesis, x, right parenthesis, x plus 4. Define func, left parenthesis, y, right parenthesis, y plus 4. Example. When the programmer, for legitimate reasons cannot tell if the previous definition exists, the if-ndef command can be used to test for an existing function so that a redefinition can be avoided. If-ndef max table size. Define max table size 1000. Endif. This idiom is particularly useful with implementations that allow macro definitions in the command that invokes the C compiler. For example, the following Unix invocation of C provides an initial definition with the macro max table size as 5000. The C programmer would check for the definition as shown below. cc-c-d max table size equals 5000 prog.c. I believe that was a invocation through the terminal, if I'm not mistaken, which I very likely could be. Although disallowed in standard C, a few older preprocessor implementations handle #define and #undef so as to maintain a stack of definitions. When a name is redefined with #define, its old function is pushed into a stack, and the new definition replaces the old one. Onto a stack, sorry, not into. When a name is defined with #undef, the current definition is discarded, and the most recent previous definition, if any, is restored. References: #define, command 3.3, #ifdef, and #ifndef, command 3.5.3. Okay, we're rolling forward with more freaking C. Thankfully, there's only about 5 more pages until I'm done, so that's that. So that's Le Epic. So yeah, I mean, hey, let's keep rolling on. 3.3.6 precedence errors in macro expansions. Macros operate purely in textual substances, macros operate purely by textual substitution of tokens. Parsing the body into declarations, expressions, or statements occurs only after the macro expression process. This can lead to surprising results if care is not taken. As a rule, it is safest to always parenthesize each parameter appearing in the macro body. If the entire body is syntactically an expression, it can also be parenthesized. Example. Consider this macro definition. Pound define square left parenthesis x right parenthesis x times x, or asterisk, but going forward I'm just going to read it as the mathematical notation instead of the exact characters, just because it flows a little bit better. The idea is that square takes an argument expression and produces a new expression to compute the square of that argument. For example, square left parenthesis 5 right parenthesis expands to 5 times 5. However, the expression square left parenthesis z plus 1 right parenthesis expands to z plus 1 times z plus 1, which is parsed as z plus left parenthesis 1 times z right parenthesis plus 1, rather than the expected left parenthesis z plus 1 right parenthesis times left parenthesis z plus 1 right parenthesis. A definition of square that avoids this problem is pound define square left parenthesis x right parenthesis left parenthesis x right parenthesis times left parenthesis x right parenthesis. The outer parentheses are needed to prevent misinterpretation of an expression such as left parenthesis short right parenthesis square left parenthesis z plus 1 right parenthesis. References: cast expressions 7.5.1, precedence of expressions 7.2.1. 3.3.7 side effects in macro arguments. Macros can also produce problems due to these side effects, but the macro's actual arguments may be contextually replicated. They may be extended more than once. The side effects in the actual arguments may occur more than once. In contrast, a true function call with I'm gonna reread that last sentence too because it was weird. Because the macro's actual arguments may be textually replaced, they may be executed more than once, and the side effects in actual arguments may occur more than once. In contrast, a true function call, which the macro invocation resembles, evaluates argument expressions exactly once. So any side effects of the expression occur exactly once. Macros must be used with care to avoid such problems. Example. Consider the macro square from the pointer example, and also a function square that left parenthesis almost right parenthesis that does almost the same thing. Int square left parenthesis int x right parenthesis left curly bracket return x times x semicolon right parenthesis. The macro can square integers or floating point numbers. The function can square only integers. Also, calling the function is likely to be somewhat slower at runtime than using the macro. But these differences are less important than the problem of side effects. In the program fragment, a equals 3, semicolon, b equals square, left parenthesis, a plus plus, right parenthesis, semicolon, the variable b gets the value 9, and the variable a ends up with the value 4. However, in the superficially similar program fragment, a equals 3, semicolon, b equals square, left parenthesis, a plus plus, right parenthesis, colon. I should clarify that there's a lowercase and an uppercase square. The lowercase square uses the squirrely brackets, and the uppercase square uses the statement expression. The variable b may get the value 12, and then that most recent one I read was capital square, when the one above it was lowercase square. The variable b may get the value 12, and the variable a may end up with the value 5 because the expression of the last fragment is a equals b, or sorry, a equals 3, semicolon, b equals left parenthesis, a plus plus, right parenthesis, times left parenthesis, a plus plus, right parenthesis, semicolon. Left parenthesis, we say that 12 and 5 may be the resulting values of b and a because standard C implementations may evaluate the expression left parenthesis, a plus plus, right parenthesis, times left parenthesis, a plus plus, right parenthesis in different ways. See section 7.12, right parenthesis. References, increment operator plus plus 7.4.4. Heh. What did I miss when I went to go do something? Some reading, some chapters, some things. Bub's talking about Quiznos. That's effectively everything that happens. So hey, welcome back. Also, hey, while we're nearing the end, friendly reminder to sub and like because it is that time. And hey, motivation is cool. That is all. 3.3.8, converting tokens to strings. Whoop. There is a mechanism in standard C to convert macro parameters, left parenthesis, after expression, right parenthesis, to string constants. Before this, programmers had to depend on a loophole in many C preprocessors that has achieved the same result in a different way. In standard C, the pound token appearing within a macro definition is recognized as urinary, quote, stringization, unquote, operator that must be followed by the name of a macro formal parameter. During macro expression, the pound and the formal parameter name are replaced by the corresponding actual argument enclosed in string quotes. When creating the string, each sequence of white space in the arguments token list is replaced by a single space character. And any embedded quotation or backslash character are preceded by a backslash character to preserve their meaning in the string. White space at the beginning and end of the argument is ignored. So an empty argument, left parenthesis, even with white space between the commands, right parenthesis, expands to the empty string, quote unquote. There's nothing in between that quote. It was just how it was. Example. Consider the standard C definition of macro test. Pound define test left parenthesis, a comma b, right parenthesis, printf left parenthesis, pound a, quote, left angled bracket, unquote, pound b, quote, equals %d, new line, unquote, comma, left parenthesis a, right parenthesis, left angled bracket, left parenthesis b, right parenthesis, right parenthesis. The statement test, left parenthesis, 0, comma, 0x ffff, right parenthesis, semicolon, test, left parenthesis, apostrophe, new line, apostrophe, comma, 10, right parenthesis, semicolon, would expand into printf, quote, 0, unquote, quote, left angled bracket, unquote, quote, 0x ffff, unquote, quote, equals %d, new line, unquote, comma, left parenthesis, 0, right parenthesis, left angled bracket, left parenthesis, 0x ffff, right parenthesis, semicolon. Printf, left parenthesis, quote, apostrophe, backslash, new line, apostrophe, unquote, quote, left angle bracket, quote, quote, 10, unquote, quote, equals %d, new line, unquote, comma, left parenthesis, apostrophe, new line, apostrophe, right angle bracket, or sorry, right parenthesis, left angled bracket, left parenthesis, 10, right parenthesis, semicolon. After concatenation of adjacent strings, these become printf, left parenthesis, quote, 0, left angled bracket, 0, x ffff, %d, new line, unquote, comma, left parenthesis, 0, right parenthesis, left angled bracket, left parenthesis 0xFFFF right parenthesis semicolon printf left parenthesis quote apostrophe backslash n apostrophe left angled bracket 10 equals %d new line unquote comma left parenthesis apostrophe backslash n apostrophe right parenthesis left angled bracket left parenthesis 10 right parenthesis semicolon. A number of non-standard C compilers will substitute for macro formal compile parameters inside string character constants standard C prohibits. Example. In these non-conforming C implementations, the test macro could be written this way. Pound define test left parenthesis a comma b right parenthesis printf left parenthesis quote a left angled bracket b equals %d new line unquote comma left parenthesis a right parenthesis left angled bracket left parenthesis b right parenthesis. The result of expanding test left parenthesis 0 comma 0xFFFF right parenthesis would resemble the stringization printf left parenthesis quote 0 left angled bracket 0xFFFF equals %d new line unquote comma left parenthesis 0 right parenthesis left angled bracket left parenthesis 0xFFFF right parenthesis semicolon. However, the expression of test left parenthesis comma backslash n not comma sorry apostrophe new line apostrophe comma 10 right and parenthesis would almost certainly be missing an extra backslash at the output of the printf function would be garbled with an unexpected line breaks in the output. Printf left parenthesis quote apostrophe new line apostrophe backslash 10 left angled bracket 10 equals %d new line unquote comma left parenthesis apostrophe new line apostrophe right angle or left parenthesis right parenthesis left angled bracket left parenthesis 10 right parenthesis semicolon. The handling of white space in non-ISO implementations is also likely to vary from compiler to compiler. Another reason to avoid depending on this feature except in standard another reason to avoid depending on this feature except in standard C implementations. Also, to answer your question, Adam.
User Atom1 Creeper says, is this on?
Yes. I just have it paused so it doesn't mess me up with reading because boy howdy that would be a nightmare. Hey, look at funny computer number over there 1024. Funny number. Me when needs return type unsigned int function returns unsigned int. What more do you need? C++ compiler. Hard to see without reading. That's all I can say. Yeah, I don't know. It's fun. I'm gonna take another mouthful of popcorn and carry on. Because holy frickin' scheisse. I hope you all appreciate how much of a pain in the ass that was for me to read. Like, come on. Come on. Like, I know this is, like, the most YouTuber stereotypical asshole thing to do, but, like, come on. Like, I deserve, like, a like and or sub from that. Like, come on. Come on. How much manual is there? Oh, I'm so glad you asked. There's 500 pages. Like 500 and change. And I'm currently on page 56. Basically 57. Isn't that fun, kids? Are you actually? Am I actually what? Am I actually what, huh? Oh yeah, I'm committed to doing this right now. I'm not even kidding, like in the slightest. I am fully committed to actually reading all of this. Like cover to cover basically, minus like some stuff like the index and some of those fluff pages. I'm subbing right now.
Do it, nerd. Then you won't see my live streams come up. Mwahaha. The live streams like to hang out in, and therefore no more insane furry VTuber who's losing their mind slowly. And is going absolutely fucking insane. So yeah, I don't know. That's where we're at. In reality, I'm not your maker. Do as you wish. But yeah. I am fully committed to the pain right now. So, good for me, I guess. I learned C++ by using it. I didn't read a 500-page manual. I know. Most people don't. And I know a good chunk of C++. But, like, I'm just going through it anyways. Because, like, fuck it. I'm mentally insane. And I will say this actually has taught me some stuff, which is neat. Like, it gave me probably the best definition of macros that I've experienced to date. So that's neat. So I would say I am probably above average when it comes to using macros now. So that's neat. And yeah, content. At some point, I unironically plan to, like, cut most of this down and, like, legitimately condense it into a, like, I don't know, it'd be something ridiculous, probably like a 20-hour video. Just a massive fucking video of just reading the C manual. Which every person will be pain or pleasure to read. And also Ari, how you said, "Oh my god, you're still doing this LMFAO." Yeah, I'm actually committed to doing this. Like, I'm actually going to read this cover to cover. I'm not even kidding. I'm fully committed. I'm at page 56, so I am approximately 10% of the way through, give or take. Not exactly, but approximately. So if you want to know how mentally insane I am, this is a good idea of how. This is my, like, forged in fire moment. This is like my suffering arc, where, like, you have, like, this mentally insane character who's, like, kind of like an anti-hero on, like, the side, who's, like, insane. Oh, that was a question? I mean, I guess... Oh, that was never a question, yeah. I mean, hey. Hey. I am a streamer. I need to fill dead air, and I'm not gonna fucking talk while I'm eating popcorn, or, like, read the manual while I'm eating it. So, yeah, that's a wonderful... I got popcorn. Okay, well, I guess I'll continue suffering. Actually, let me crack one more of a cold boy, and then actually no, I'm gonna stick to water. Tomorrow's gonna fucking suck, so I'm gonna prepare myself for suckage. Better than some of my friends who just piss while still unmuted. Yes, sorry, I don't know why my brain just shuffled the words unmuted and muted, so I'm like, muted? That doesn't seem like I read unmuted as, like, muted, and I was like, what the hell? Yeah, I don't know. Anyways, better than some of my friends who piss while unmuted. Friends, yes. I mean, hey, you could always just get the friend pin instead, which never needs to piss. Welcome to friendage. Anyways, I guess I shall carry forward with pain. So, hey, don't mind me, I guess. 3.3.9, token merging in macro expressions. Merging of tokens to form new tokens in standard C is controlled by the presence of the merging operator ##. Two pounds hashtags right beside each other. In macro definitions. In a macro replacement list, before rescanning for macros, The two tokens surrounding any pound pound operator are combined into a single token. There must be such tokens. Pound pound must not appear at the beginning or end of a replacement list. If the combination does not form a valid token, the result is undefined. Pound define, temp, left parenthesis I, right parenthesis, temp, pound pound I. Temp left parenthesis 1 right parenthesis equals temp left parenthesis 2 plus k right parenthesis plus x semicolon. After preprocessing, this becomes temp 1 is equal to temp 2 plus k plus x. In the previous example, a curious situation can arise when expanding temp plus x. The macro definition is valid, but plus plus is left with no right-hand token to combine left parenthesis unless it grabs plus, which we do not want, right parenthesis. This problem is resolved by treating the formal parameter I as if it expanded to a special quote empty unquote token just for the benefit of pound pound. Thus, the expansion of temp plus x would be temp plus x as expected. Token concatenation must not be used to produce a universal character name. As with the conversion of macro arguments to strings, left parenthesis, section 3.3.8, right parenthesis, programmers can obtain something like this merging capability through a loophole in many non-standard C implementations. Although the original definition of C explicitly described macro bodies as being sequences of tokens, not sequences of characters, nevertheless, many C compilers expand and rescan macro bodies as if they were character sequences. This becomes apparent primarily in the case where the compiler also handles comments by eliminating them entirely, left parenthesis, rather than replacing them with a space, right parenthesis. A situation exploited by some very cleverly written programs. Example. Consider the following example. Pound define inc plus plus, pound define tab internal underscore table, pound define increment tab space table underscore of underscore increments, pound define concat left parenthesis x comma y right parenthesis x begin comment end comment y concat left parenthesis inc comma tab right parenthesis. Standard C interprets the body of conc concatenate as two tokens x and y separated by space. Comments are converted to a space. Left parenthesis comments are converted to a space, right parenthesis, to call concat left parenthesis inc comma tab right parenthesis expands the two tokens inc tab. However, some non-standard implementations may simply eliminate the comments and then rescan the macro bodies for tokens. These expand concat left parenthesis inc comma tab right parenthesis into a single token inc tab. Table with three headers. Step, standard C expansion, possible non-standard expansion. Carrying forward. Step 1. Concat left parenthesis inc comma tab right parenthesis possible standard non-standard expression concat left parenthesis inc comma tab right parenthesis. Step 2 inc begin comment end comment tab possible non-standard expression inc begin comment end comment tab. Step 3 standard C expression inc space tab possible non-standard expansion inc tab one word no space. Step 4 plus plus internal underscore table possible non-standard expansion table underscore of underscore increments. References: increment operator plus plus 7.5.8 universal character name 2.9. Isn't C++ cool? Oh my god. Okay. Considering I don't see any chat messages, I'm just going to keep on rolling. 3.3.10 variable argument lists and macros.
In C99, a function-like macro can have its last or only functional parameter and ellipses, signifying a macro may accept a variable number of arguments. Pound define, name, left parenthesis, identifier dash list, comma, ellipses, right parentheses, sequence dash of dash tokens, subscript opt, pound define, name, left parentheses, ellipses, right parentheses, sequence dash of dash tokens, subscript opt. When such a macro is invoked, there must be at least as many actual arguments as there are identifiers and identifier dash list. The training arguments include any separating commas as merged into a single sequence of preprocessing tokens called the variable arguments. The identifier __va _args _ appearing in the replacement list of the two macro definitions is treated as if it had been a macro parameter whose argument was the merged variable arguments. That is, __va _args _ is replaced by a list of extra arguments, including their comma separators. __va _args _ can only appear in a macro definition that includes ellipses in its parameter list. The macros with a variable number of arguments are often used to interface to functions that make a variable number of arguments, such as printf. By using the pound stringization operator, they can also be used to convert a list of arguments to a single string without having to enclose the arguments in parentheses. Example: these directives create a macro my _printf that can write as many arguments either to error or standard output. %ifdef debug, pound define my _printf left parenthesis ellipses right parentheses, fprintf left parentheses standard error, comma, __va _args _ right parenthesis, pound else, pound define my _printf left parenthesis ellipses right parentheses, printf left parentheses __va _args _ right parentheses, pound endif. It may be used this way: my _printf left parentheses quote x equals %d new line unquote. I think it was quote x. I think I said that, but whatever. Unquote, comma, x right parentheses semicolon. Example: given the definition, pound define make _m _a string left parenthesis ellipses right parentheses pound _va _args _ the invocation make _m _a string left parentheses a comma b comma c comma d right parentheses expands to the string quote a comma b comma c comma d right parentheses, or unquote, sorry, not right parentheses. Why is YouTube being so silly? Let me restate it. Vol, have you ever tried the new flavor of Monster? Which one is that? Because I tried frickin' I think it's like a purple one. Tasted like Kool-Aid basically today. My two mains are like Ultra Rosa and like the strawberry one. Pretty much every other one I've tried, in my opinion, has kind of been garbage, in my opinion, and I don't think Monster should taste that good. Yeah. What about Chew? Ultra Guava Vice. No, I don't think I've tried that. I also only drink like the zero sugar one, so that might also be another reason. Femboy Monster flavors, yeah. C-Bubs gets it. He understands. I'm gonna now chug some frickin' popcorn. Because that is my dinner, because I'm bad at making life decisions. Oh. Okay. Okay. Hopefully I finished suffering through that. Oh, also,
I completely forgot to mention, for any of you who care, I actually made a small update to the stream. Currently, now with streaming, I believe the entire thing is still being recorded in 1080p. I think it's actually 4K, it's saying. Well, I don't know what it's outputting as to YouTube, but long story short is I think we're doing 4K in 48 FPS, so it should be pretty smooth. Or at least smoother. Not quite 60 because I did some loose math and my max 1080p. Okay, well it's 1080p at 48 FPS now. Reason being is that before my I'm pretty sure I did some math with like what my ISP can provide, and I'm pretty sure this is like my approximately maxed out bandwidth value that I can send. So you're getting all the data I can provide. Random freezing though, that's weird. That might also be a YouTube thing. Anybody else in chat, if you're present, have you noticed any other random freezing? Is that a YouTube thing or nah? Because I've had it set to this for like a couple streams that I just completely forgot to mention. Like it's been this way for probably like 2 weeks, I think now. So hey, let me know. I'm gonna start reading this next chapter. And then by the end of this chapter, hopefully I'll have some other chime-ins and we'll go from there. Let's see. 3.3.11, other problems. Some non-standard implementations do not perform string ENT error checking on macro definitions and calls, including permitting an incomplete token in the macro body to be completed by text appearing after the macro call. The lack of error checking by certain implementations does not make clever exploitation of the lack of legitimate standard C reaffirms that macro bodies must be sequences of well-formed tokens. Put vote? I don't know if I can make a vote. I can do a poll. Poll. Let's see. Have you noticed any freezing or freezing from the stream? Question mark. Yes, yesum, nosum. Start poll. So there's the poll. It has appeared magically. I realize I have chat integration, so that's freaking wonderful. Like unironically. So everybody, duke it out. Vote. Go to the poll. Vote now. Vote on your champion. I will read this next thing while that poll does its thing, and then after we do so, then we will see what's going on. Some non-standard implementations. I'm just going to read this whole chapter again. Sorry. 3.3.11 other problems. Some non-standard implementations do not perform string ENT error checking on macro definitions and calls, including permitting an incomplete token in the macro body to be completed by text appearing after the macro call. The lack of error checking by certain implementations does not make clever exploitation of that lack legitimate. Standard C reaffirms that macro bodies must be sequences of well-formed tokens. Huh. Example. For example, the following fragment in one of these non-ISO implementations. Pound define, first part, quote, this is a split, ellipses, printf, left parenthesis, first part, string, period, unquote, right parenthesis, semicolon, comment start, yuck, uncomment, will after pre-processing result in the source text, printf, left parenthesis, quote, this is a split string, unquote, right parenthesis, comma. 3.4, file inclusion. The pound include preprocessor commands causes the entire contents of a specified source text file to be processed as if... Oh, sorry, I should actually not read here. So everybody right now is saying yes to there being stream errors. So
If it's just freezing, then let me know. I'm actually curious how many people voted, because there might only be one person that voted on it. I have no heckin' idea. So let's actually check that. How do I check that? One vote. Awesome. Well, a vote of one person is not very epic. So what I will do is, once again, hey everybody, go vote. Vote. There is a vote thing happening. Do the vote. Do the vote. If you don't vote, you're stupid. You're stupid. Your brain's smooth like chicken breast if you don't vote. Click an answer. Point of view, U.S. government. Yeah. Yeah, C-Bubs, are you just going to take that? Are you just going to let the U.S. government be shamed like that? Well, yeah, I guess I'll continue reading, and then hopefully by the end of it, we have some more results, because, yeah, that's a sad amount of votes. 3.4 file inclusion. The #include preprocessor command causes the entire contents of a specified source text file to be processed as if those contents had appeared in the place of the #include command. The #include command has the following three forms in standard C. #include left angle bracket h-char sequence right angle bracket #include quote q-char sequence unquote #include preprocessor tokens left parenthesis standard C right parenthesis. I'm going to go take a shower. BRB in 24 hours. Fair enough. I will confess that I'm going to be wrapping up soon. So, oodles. I broke my rule. In the first two forms of #include, the characters differ between the delimiters. Sorry, I'm just going to reread that. In the first two forms of #include, the characters between the delimiters should be in a file name in some implementation defined format. There should only be white space after the closing right angle bracket or double quote, which I'm assuming is the closing quote. These two forms of #includes are supported by all C compilers. The file name is subject to trigraph replacement in standard C and source line concatenation, but no other processing of the characters occurs. In the third form of #include, the preprocessor tokens undergo normal macro expansion, and the result must match one of the first two forms. Left parenthesis, including the quotes, are angle brackets, right parenthesis. This form of #include is seen less often and may not be implemented or may be implemented in a different fashion in non-standard compilers. Example. Here's one way to use this third form of #include. If some underscore thing equals this underscore thing, define include file, quote, this name.h, unquote, else, define include file, left angle bracket, that name.h, right angle bracket, endif, ellipses, include file. This style can be used to localize customizations, but programmers interested in compatibility with older compilers should instead place #include commands at the site of the definition commands earlier. If some underscore thing equals this underscore thing, include, quote, this name.h, unquote, else, include left angled bracket, that name.h, right angled bracket, endif. File name syntax is notoriously implementation independent, but standard C requires that all implementations permit file names in #include consisting of letters and digits, left parenthesis, beginning with a letter, right parenthesis, followed by a period and a single letter. C99 allows up to 8 letters and digits before the period, but C89 only guarantees up to 5 letters before the period. By permit, we mean that the file names in this form must be mapped to an implementation defined table. File. Not table. File. Files delimited by quotes and files delimited by angle brackets differ in how they are located by the C implementation. Both forms search for the file in a set of left parenthesis, possibly different, right parenthesis, implementation defined places. Typically, the form pound include left angle bracket file name, right angle bracket, searches for the file in certain standard places according to implementation-defined search rules. These standard places are usually contain the implementation's own header files, such as standard.io.h. The form pound include quote file name unquote will also search in the standard places, but usually after searching some local places such as the program's current directory. Often implements having some standard way outside of the C language for specifying the set of places for to search for these files. The general intent is that the quote ellipses unquote form is used to refer to header files written by the programmer, whereas left angle bracket ellipses right angle bracket form is used to refer to standard implementation files. In fact, standard header files like standard.io.h are treated as special cases in standard C. Standard C requires that implementations recognize the standard library header names when they appear in angle brackets, delimited pound include commands. That's very awkward to read. I'm gonna try to read that again. C requires that implementations recognize the standard library header names when they appear in angled brackets, delimited pound include commands. I don't know how I'd read that. I'm sorry. But there's no requirement that these names specify true file names. They can be handled as special cases. They're constant simply quote known unquote to the C implementation. For this reason, the standard calls standard headers and not standard header files referred to both ways in this book. An included file may contain pound include commands, permitted depth of such pound include, nesting and implementations dependent of standard C requires support for at least 8 levels, left parenthesis, 15 levels in C99, right parenthesis. The location of included files can affect the search rules for nested files. Example, suppose that we are compiling a C program first.c in the file system directory /near. The file first.c contains the lines comment start in /near /first.c end comment pound include quote /far /second.h unquote, which specifies that second.h is to be found in the directory /far. The header file second.h contains the lines comment begin in /far /second.h pound include quote third.h unquote, which specifies no directory. Will the implementation choose the file /near /third.h in the original working directory, or will it choose /far /third.h in the directory of the file that included it? Some Unix C compilers would find /far /third.h the original description of C, so it seems to suggest that /near /third.h should be found. Most implementations let the programmer specify listed directories to search in order for included files whose directories are not specified. References: string constants 2.7.4, trigraphs 2.1.4. Okay. And what page am I on right now currently? 62. Okay. I do apologize. I'm going to be cutting the stream short today, quote unquote short, it's a 2.5 hour stream. Simply for the reason that, as I mentioned before with work, I have to skedoodle early in the morning. And I'm going to have to do a bunch of stuff to get ready for tomorrow morning. So I want to try squeezing the stream anyway for y'all. Yeah. So I will thank everybody for watching. If you enjoyed the stream up to this point, don't forget to subscribe for more streams in the future. Don't forget to do the like and comment shit, because that's generic YouTuber stuff. And thank you all for tuning in. Hope you enjoyed. I should be back on, what would it be, Friday night, unless something goes wonky, roughly 7 to whenever. And, yeah, hope you all have a fun time, and, see you next stream. Bye-bye.